Waves carry energy through space, but they move particles in fundamentally different ways. Today, we will compare transverse and longitudinal waves by defining their particle motion, structure, and key differences. First, wave propagation describes the direction that energy travels through a medium or space. In a transverse wave, the particles move up and down perpendicular to the wave's propagation direction. The highest point of this wave is called the crest, and the lowest point is called the trough. Amplitude measures the vertical distance from the center line to a crest, showing the wave's energy. Wavelength is the distance measured from one crest to the very next crest in the sequence. A great example of a transverse wave that does not need a medium is visible light moving toward you. Now, let's look at longitudinal waves where particles move back and forth along the propagation path. This means the particle motion is parallel to the direction the wave energy is traveling. Areas where particles are squeezed together tightly are called compressions. The stretched out areas where particles are sparse are known as rarefactions. For a longitudinal wave, the wavelength is the distance between two consecutive compressions. Frequency describes how many full waves, crests or compressions, pass a fixed point each second. Sound waves are the primary example of longitudinal waves because air particles vibrate back and forth to carry the energy. To visualize the difference, imagine shaking a long coiled spring side to side to create crests and troughs. This side-to-side motion is transverse because it is perpendicular to the spring's length. Building on that, pushing and pulling the spring end creates compressions and rarefactions. This back-and-forth motion is longitudinal because it is parallel to the spring's length. You can always identify the wave type by asking if the particle movement and the energy movement are perpendicular or parallel. We learned that transverse waves move particles perpendicularly, exemplified by light, while longitudinal waves move them parallel, as seen with sound. By mastering these basic definitions, you have taken the first step toward studying the physics of light and sound. Generate your own educational videos for free at eduvids.vercel.app.